So if I was to mention something along the lines of adapting to thrive, what do you think it might mean? In today's video, I want to dive into how plant evolution has changed over thousands of years and what this means to how we care for our plants and how it can give us a bit of an edge. Hi there, my name is Memo, this is my channel, Houseplantygoodness, and essentially it's a place where I like to geek out about my big passion. You might be able to see some of it behind me, it's tropical houseplants. So yeah, as I was saying, I want to touch on evolution today, and I want to see how some plants have evolved in certain ways that has made them more adaptable to where they are used to growing, and how we as kind of plant parents, as people within the houseplant hobby, can utilize this information to supercharge our plants growing. Understanding not just the plant, but also its environment can really help you become a better plant parent. So again, let me give you an example here. So something like, let's have a look. So something like an epiphytic orchid. An epiphytic orchid is used to growing on the side of a tree in a jungle, somewhere more tropical usually. Understanding what that means in terms of climate, temperature, light, the moisture that it's receiving around its roots, the moisture that it's receiving around itself totally, what nutrients it might be getting in that situation, all of these things will play a part as to how that plant has adapted. And sometimes those adaptations are immediately visible, and sometimes they are not, basically. So again, coming back to the example of maybe say a Phalaenopsis orchid, those roots go green and that's obviously when they've absorbed all of the water. They might go a slightly more silvery color when it's drying out. That's an adaptation that that plant has had in order to be able to deal with the environment that it's growing. So a couple of other adaptations, you might look at this, and I think this is, why can I never remember this plant? This is the Philodendron Pinnatillobum affinity. So you might have seen other plants that have got this. My Esmeralda dense philodendron has got this here. Plants that have got the leaves drop down like this with a very significant peak pointing downwards instead of upwards. So what this might mean is this plant is adapted so when it's got heavy rain coming through it, it will slough up all the water down off the plant. It also means that if this is growing on the side of a tree, it wants its leaves to be pointing towards the light direction as well. So things like these are adaptations. You might see sometimes with alocasias where the leaves would point upwards is because they are trying to capture as much of that water to come into the crown of the plant because they are used to growing near waterways. So they like moisture around their roots. There's another anthurium, I've got an anthurium arrow, and I will take a picture and add it here so you can see at the sinus point of where that leaf attaches to the petiole, which then attaches to the growing stem of the plant, there's almost like a channel that's created. Again, it creates a bit of a cup where the water would come into and then drop down that channel again to go into that root, into that crown of the plant, which to me means that it's adapted to wanting to collect some more of that water around its crown and its root mass. Not the best looking example of a calathea, but a calathea white fusion that's looking a bit problematic at the moment. It's not dead, but it's okay. This is one that has got probably one of the most obvious adaptations that we can see quite clearly from most calatheas, which is that nighttime opening and moving and closing of those leaves during the different times of the day. That is an adaptation, again, to its environment. We've talked about this before because if the leaves are up at night and they've got those darker backs, they might not be as visible to herbivores that are trying to munch away at plants. At least that is one of the theories. Let's dive into aroids. And I know everybody's sick and tired of listening about aroids, but I've done it as a first section so we can talk about other subsections later on in the video. But aroids are used to living that kind of airy breezy, airy fairy life, basically. Because side of trees, potentially, especially if they're epiphytic aroids, they're used to getting more kind of air towards their roots. Now, let's talk about some examples here. And again, I will bring a picture here of an epiphytic Aroid, which in this case is an orchid that I've got. Many orchids that I've got mounted as well. Same thing goes for something like a staghorn fern. All of these things, and actually staghorn fern is a good example. Again, I'll bring up my example of my super bam staghorn fern, which I can tell you for a fern, a lot of the times the soil will go bone dry and then I will re-wet it absolutely fine. Unlike some of the other ferns that are used to growing in dense soil at the jungle floor. And that is also important to remember. Where within their habitat are they growing? Not just the altitude, how far up they are, maybe on a mountain, especially if they're in something like a cloud forest. And another example of an orchid that I've got here and how it's adapted. So this is Dracula Surlei orchid. And this one's got an adaptation to the lower temperatures, which means that it needs those lower temperatures in order for the blooms to open. Examples of some people that have been here for a while. I still have not got this plant to bloom because I have never managed to get it cold enough when it's got, so it will get the flower spike, but it will never burst into a bloom because I've never got it cold enough in here, because it will probably kill the rest of my plants. Am I okay with this? Kind of. Am I a bit salty with this? Probably. But it's okay because the rest of the plants are happy. Adaptations. So that's an adaptation of kind of its scenario of it being at a higher altitude, which means it can handle and it almost expects that colder temperature as well as that high humidity because it's in a cloud forest. And then something polar opposite of that would be at the very base of the jungle floor, like the calathea that we were looking at before, something near a waterway, which would be this is the Alocasia gagiana variegata. So that's expecting a different type of situation there, maybe more moisture around its roots all the time. And again, possibly a warmer climate, possibly a bit more dappled shade because it's so low on the jungle floor, things like that. Same thing goes for the fern as well. But let's talk about some certain types of plants as well, like plants that will grow up something. So an example of that might be, actually let me show you an orchid. So this is a Balbophyllum orchid. One of its oldest leaves is looking like it's going to yellow off and dry off quite soon. But let me show you some of the new pseudobulbs that are coming through there. Can you see the roots that are happening there? If I show you some of the other roots, hopefully that might be coming through. If that will focus right where my finger is. Can you see those kind of lighter colored roots that are wrapping around another Balbophyllum? They're attaching. This is how this plant might be growing in nature, and obviously not in a pot, but it will send off these pseudobulbs, which then have its own root system. These roots are adapted to be able to absorb some of the moisture from the air, but also if they find something to attach to, they will then start wrapping around that to give it a bit more stability. So these are a lot of very significant adaptations that this specific aroid would have in order for it to grow in its natural habitat. The point I'm trying to make with this is, keeping it like this means that the plant is experiencing what it would do in nature. Could I make this life a bit easier by maybe giving it something close like a plank, so if it finds it, it could attach to the plank the same way that it might attach to the tree? Yes. Is it stressing this plant out? No. But at the same time, what I don't want to be doing is taking all of these pseudobulbs and going, oh, your roots are trying to find soil. Let me put a little bit of butt here so you've got soils for that roots to go in. No. Go with what that plant is expecting due to its adaptation. And again, think about where some of these plants are growing. So if jungle floor again, if they're in the jungle floor, they're expecting lower light levels because the light would dapple through all the leaves of all the other trees around it. It's getting the least amount of light rather than something that might be climbing up a tree and getting close to that top of that canopy. So that's one thing. And also think humidity levels lower down as well, because if all of that is keeping lower light levels, is probably keeping humidity down. So the humidity down here at the base is likely going to be higher than right at the top, where maybe there's more wind flowing through and there's still high levels of humidity, but not as high as right at the very base of the jungle floor. Again, because there might be some moisture as well coming in from underground there. Let's look at leaf adaptations next. And I talked about this earlier again. I will show the example of the Anthurium arrow with that channel going through. bringing in that moisture to the center. Same thing would go for something like a bird nest fern. It is kind of attracting all of that water to go into the crown. The most notable adaptation, and I'm trying to see, do I have one that I can pick up to show you? They're looking a bit busted, but I will show you. Actually, no, I won't show you that one. I will put a picture here of something that looks a bit better so you can kind of see it. A lot of the monsteras. Think Monstera deliciosa, think Adansonii, think Obliqua even as well. And obviously there's been a lot of hot debate about what causes or why the plant feels the need to have the splits on the leaves or even the holes that are happening within the leaves. But one of the theories, there's two theories that are predominant. One would be because if it's going anywhere that's really, really windy, the leaves won't snap or break because the wind will go through all those holes and splits. The other one being that if it's growing up a tree and the leaves are getting bigger as it grows higher up, it is naturally going to shade the rest of its leaves further down. So by having those splits and those holes, it's allowing filtered light to go through to some of those lower leaves to keep itself happy. Otherwise, it would be killing itself. So it probably doesn't want to be doing that. So which one of these things, there's a lot of other theories as well, but which one of these two theories isn't for me to debate within this video, but it's nice to us to kind of have that concept in our mind when thinking about plant adaptations and how some of these plant leaves might be adapted to their environment. And what does this mean? Think about it. If it's for dappling of the leaves, of the light within the leaves, it means that this plant would like some bright indirect light, but maybe some of the lower leaves could deal with some medium light as long as the ones at the higher levels are getting a bit more of a brighter light, again because it's climbing up a tree and it's getting close to that canopy, so close to getting more direct light at that point. Same thing will go with a lot of the plants that have got hairs on them, hairs on the leaves. So pubescence is the word there. So hairy leaves are leaves with pubescence on them. A lot of the times that might be to conserve moisture, but also to repel moisture. I don't know if you've ever seen very, very fuzzy leaf plants and it rains, the water just kind of beads off the hair and drops off the plant as well. That is another adaptation, and that is telling you what the plant prefers and what it does not. So go along with that just so that you know that you're giving your plant its best possible care, because I have said this before and I will say this until I'm blue in the face. We are the sole caretakers of these poor plants that are growing not in nature where they are meant to grow, but in our household, which is a weird environment at the best of times for them. But we are solely responsible for the light they get, the water they get, and the nutritions that they get. So anything that we can know about how they've adapted for their specific conditions in a jungle will be important. Just because they're growing in a household now doesn't mean that they're adapted to that. So you might want to go in line to what they're adapted to dealing with. Talking again about the calathea that I was just talking about before, those are plants that are growing at the jungle floor. Now, what you're expecting, the higher humidity levels, lower light levels. People know, people that have been growing calatheas for a long time know, don't put it anywhere near direct light, it will burn to a crisp. It's not what it's expecting, it's not what it's adapted to. Same thing goes for that movement as well. I don't know if anybody's ever done this or why they would want to do this, but if they've ever kept a calathea under light all the time, so under a grow light without ever switching it off and giving it a nighttime rest. Tell me if you've ever done that. A, why have you done that? It sounds a bit cruel. But also, what were the results? I'm really curious. For a plant that's expecting to move its leaves up and down night and day, I'm curious. Obviously, that's an adaptation potentially away from predators. But I'm curious to see what that did to the plant. Did it really struggle and throw a complete wobbly? Let me know. How about we touch on kind of root and water adaptations that some of these plants might have? And actually, a root adaptation, example of the Alocasia. Why did I forget that? The Alocasia gaggiana variegata. This is a variegated one, but it would apply to a lot of the alocasias, colocaceas, all of these things. They are used to growing near waterways. What does this mean in terms of their adaptation? They can handle their roots being a bit wetter for a bit longer. However, they are not a carnivorous plant which is growing near bogs. So that's the other extreme. So if you're going to have something like a Sarracenia, which is used to growing near boggy waters where it constantly wants moisture around its roots, and you put something like an alocasia there, is it going to love life? No. Is it probably going to perish? Yes. Conversely, if you put something that is a carnivorous near the kind of areas where this might grow, it might not also be entirely happy. They can be quite similar in their needs, so they might not die off entirely, but I'll give you a more extreme example. How about you put something like a Phalaenopsis orchid, something that's used to very, very airy conditions, and shove it in a bog? That's going to perish very, very quickly because it's not getting enough air around its roots, which is what it's expecting. Same thing if you take a carnivorous plant, I've mentioned this in another video, and shove it on the side of a tree where it gets all the air exposure and the roots dry out to a crisp. What's probably going to happen to that carnivorous plant? It's probably going to perish as well. So go along the lines of its adaptations. Now, the other adaptation that you might consider in terms of how this might be growing, and I'll show you right there. Can you see this swollen base there? So that is how it adapts, because actually, if I'm not mistaken, alocasias and colocasias need a lot of moisture because that is what's keeping, this is a very small example. I'll hopefully find a big example and put it here or put it over myself if it's a video. Very, very large leaves and they need to stay upright. That is created by utilizing water to kind of keep all of this out. It's very, very interesting. Look at the structures of the inside of a petiole of an alocasia and colocasia and the leaves as well. It's very interesting about how they utilize water and how they've adapted in that way. So that's one thing. So they've got the swollen kind of the corm, which think about it like an overgrown potato potentially if you want. And then let me show you a couple of other examples. Similar adaptation, but adaptation to lower water levels. How about this? We haven't seen a ZZ on my channel for a very long period of time. So ZZ plants, have a look at where ZZ plants or Zamioculcas zamiifolia have originated from. These plants, if I'm not mistaken, originate from Africa. Think about generally what the situation might be in the most traditional way when you think of kind of some of the African nations. It doesn't apply to all of them, that is a common misconception, but they might have slightly more arid and dry conditions. So what this plant does is, can you see how thick that growing stem is? So it stores some water there, and also, unfortunately, this one isn't large enough for me to show you anything at the moment, but if anybody's seen this, a larger version of this, they've seen some little bumps that happen in the soil, and those really do look like mini little potatoes. That is part of its root system, and it contains a lot of moisture as well. So what this does is it stores water, so when it does get the moisture, it quickly absorbs it, puts it in there, so when it's got a long, long dry period, it's still got some moisture to pull from because of its structure, like that stem and like that kind of potato-looking structure that's happening within its roots. And it's also another thing that you need to remember with something like a ZZ plant. This is the one thing that people a lot of the time say, if you're watering your ZZ plant more frequently than you're paying your mortgage or your rent, you're probably watering it a bit too much. Because again, remember, you've watered this. I watered mine yesterday. It's still relatively wet, but this one had been watered about a month ago, really. And it was starting to show issues of kind of like not being 100% happy because maybe I let it go dry for a bit too long. But this is much more adapted to doing that. Can you imagine if I watered my fern, any fern, a month ago and then like left it until like a month later to water it? Would I come back to a plant that looks vaguely alive? Probably not. It would have turned to dust by that point. Exception being the staghorn fern, the super balm, or any staghorn fern, because the way that they grow off the side of trees, they're okay to go a bit drier for a bit longer than a traditional fern, which again, remember the conditions, base of a jungle floor. I'll give you one more example of a plant that's kind of adapted to drier conditions. Again, I think, if I'm not mistaken, a plant that will grow naturally within kind of Africa, the Sansevierias, or the Dracaenas now known. That entire plant is kind of a way of storing moisture. Different types of alocasias, Sansevierias / Dracaenas, that's how they store their water to deal with that drier season, very similar to the ZZ plant that we were just looking at. How about some light adaptations and placement tips as well? So think about certain things, again, your philodendrons, your climbing philodendrons, your monsteras that might be climbing that are getting closer to that canopy level. We touched on this a bit earlier on when it came to light. They are used to getting that bright indirect light, potentially, especially if they break through the canopy, because it can happen sometimes. Those leaves might get, running away with my words there. Those leaves at the very top might start bleaching out, but eventually they'll adapt a bit as well because they're getting the maximum amount of light, but everything else is still getting dappled light. So it's fine if it can sacrifice those top leaves as long as the rest of it is getting what it's expecting, which is bright indirect light, because they are getting closer to that light level. Coming back to the very base of the jungle floor, you've got your ferns, you've got your calatheas, you've potentially got some peperomias as well. A lot of the plants as well that you might see within the houseplant kind of world, or things that have turned into houseplants, the ones that have got the red backs to their leaves or the purple backs to their leaves, that's generally an adaptation of plants that are at the base level of a jungle. Those ones are used to getting medium to low light levels. So go with those adaptations, do not try to go against it. I used the example earlier on about a calathea. If you get a calathea and you put it in a bright light like you would a cactus, it will fry relatively quickly. Same thing goes that if you've got something like a cactus that is meant to be getting full sun, bright sun, because it is baking under the sun in a desert somewhere, and put it in a humid and dark place with low light, how quickly is that going to perish and rot away? Don't go against its evolution, don't go against its adaptations, go alongside of it, and that plant will be happier, it will grow more consistently and larger for you faster as well. Go with what it's expecting to find. I have said this until I'm blue in the face, but hopefully I think everybody's in agreement these days with this. And a tip in terms of placement within the household, and I've mentioned this before, get yourself a light meter app for your phone. Before the scientists all come for me, I know it is not as accurate as getting a proper light meter, like a scientific one, but those things are stupidly expensive. The light meter app on a phone is either free or very cheap. Do that and just see if you've got, say, a monstera that you know is growing super well and super fast in a specific location of your house. Use that light meter, check what light it is getting, and if you're getting another monstera and you're just wondering where am I gonna put it somewhere that has the same reading as that first reading that you took. It's as simple as that. If that monstera and a similar type of plant that's expecting a similar kind of light level gets that light level because you've already checked it in the new location that you want to put it, great. Gravy. You've got exactly what you need in that situation, and it takes a lot of the guesswork out of it. So in summary about all of these things, each adaptation tells a story about that specific plant, where it grows, what it's expecting to find, what it's not expecting to find. And if we push against it, so if we give it the wrong light level or the wrong kind of moisture level, humidity, all of these things, nutrients, soil, kind of fertilizer, all of these things will work against you. Now, I know this might worry and stress some people, especially if you're first starting off going, oh my God, there's so many different plates to spin and all these things. I get it. Also appreciate the beauty that is nature that does all of these things naturally where these plants are growing. You are basically trying to emulate a bit of that, so there's a lot to do. But even if you can't do everything, see the most dominant adaptation on the plant and try to go alongside that. So, for example, a Monstera deliciosa with the splits and the holes, give it bright indirect light as a first point of call. With something like a orchid that's expecting really airy soil media, give that first and foremost before you start adjusting anything else. Go for the most obvious visual, and it's not always going to be that easy, but go for the most visual and obvious adaptation and adjust to that first, and then you can kind of add to it as you go along the lines. For the plant geeks out there, do everything. Or do as much as you want to do. You know you're probably going to do everything. I can't stop you. I am one of you. I understand 100%. But what I'm saying is, don't overwhelm yourself. And this is more of a video that's meant to be kind of a fun and educational video to kind of start thinking about how you can adjust your care based on what the plant is expecting to find to get that better growth. And a lot of people always ask me, what do you do differently to get this? And yes, some of this is my setup with the conservatory, with the heat levels in here, the humidity levels in here, the light levels that are happening in here. But also there is adjustments that I have made to a lot of my different plants. So a lot of the plants that I grow that are from higher altitudes and are expecting a bit of a winter drop, I have found that actually letting this space get a tiny bit cooler than most people would be comfortable with. So letting it go under 20, so between 15, 16 degrees Celsius to 20 in the winter, which might be a bit worrying for some people, doesn't harm any of the rest of my plants. It gives them a bit of the rest, it gives me a bit of a rest, but it also means that it gives a bit of a boost to some of my higher altitude plants, and that's fine. And also it goes without saying that if you don't want to make some of these more significant adjustments to something like a higher altitude plant, maybe that isn't the right plant for you to be joining into your collection because it will likely stress you out. I had a very interesting conversation with, I think, one of my Greek viewers who was saying they were trying to grow a specific plant, but it did atrociously badly in Greece because it never got those lower temperatures. And they were asking, should I try this other plant? I'm just like, it's the same care, so maybe give it a miss, because unless you want some more heartache, or you can try it, but you'd need to do all these different things, and like most individuals will be like, oh no, I can't be bothered. And that's completely valid, by the way. We can't all grow all plants. We can try, but some things maybe are just not meant to be, and it's okay. People that have been doing this for a while, they get that. They get that. There is a point where it's just like one strike, two strike, you're out. Some people, it's just one strike and you're out. So adjust as much as you feel comfortable for that plant and what they're expecting, but also at the same time, it needs to be comfortable for you. There's no point of you having 1,000 plants in your space and they're all expecting 90% humidity in terrarium conditions. Even if you give that to them, you're going to be dealing with mold, you're going to be dealing with a lot more issues in your space. The plants are going to be happy, you might not be. So adjust accordingly. But yes, I've waffled on for way too much in this video, but yes. Hopefully you've enjoyed, hopefully I shall see you here soon, and I truly, truly hope that you have a great rest of your day. Thanks, bye.